This is again an isolated or a standalone subject area which you can uh, score some good marks at the examination from one point of view. And on the other hand, you should be able to understand a lot of charts and graphs that are available in the real world in the domains of finance and economics, especially um, for you to understand how a lot of them are being constructed. If you could recall, during the second session, we discussed some areas on charting and graphing. We learned how to represent the data using some of the graphical methods. Categorically, if I bring up some uh, knowledge into this area, we discussed line charts and bar charts into different variables, and we discuss how to plot them using the absolute data. So obviously, for the x-axis, you'll be taking uh, the variable, and the height or the value of the variable will be representing in the y-axis. Now, that's an absolute representation of one variable. But if you look at the real world, a lot of instances, this absolute representation doesn't really help. So sometimes we heard this word of index being used, and the change of that index being discussed heavily to understand whether a considered variable or a considered basket, the weight of that basket has been increased or decreased, and what are the root causes for that. So that sort of discussion is been there since a long time. So with the today's lesson, what we are expected to do is to understand how these indices are being constructed, what sort of methods that we can use to construct these indices, and also some of the theoretical aspect onto practical implications, then the limitations of these systems, and what to be careful when you are deciding indexes. So having said that, so hopefully we'll be covering the entire aspects of theory with the today's lecture, and probably at the next week we should be able to discuss the entirety of examination questions, uh, if or not, at least the major types of questions that have been discussed in the past couple of years of examination. So that's the plan for the day. And if I just quickly recap where we stopped last week and week before, we discussed the regression analysis extensively. We covered the theoretical areas such as simple linear regression, multiple regression. We discussed R square, coefficient of determination, and then the limitations of R square, and what to be expressed from R square, things like that. And simple linear regression, we discuss on the construction of the y equals alpha plus beta x plus error sort of an equation. And multiple regression, we discussed, okay, we don't need to really do the computation of those regression coefficient determination. Rather, we'll try to use the already existing model that has been built by somebody. So that is where we stopped, and I hope we covered the core types of examination questions with the last week's lecture, and hopefully you should be able to, provided that you get a good 20-mark question, I think you should definitely attempt that on regression. So having said that, indices is also a similar area. You may see at least a couple of MCQ questions, at least one or two short-ended answers questions also. You've been given one particular point to determine the index value, and then discussing the same, okay, what has happened to this index value in the 5 years or 10 years afterwards. And also in the structured area or the elective areas also, you may see at least 10 to 15 marks or a complete question from this indices computation when you look at the past paper examination. So this is also a very easy area for you to focus and understand the logic behind the index construction, and uh, probably apply your knowledge as to uh, constructing indices as well as recalculating bases and expressing your index values for a given set of variables. Importantly, we have to understand that we are not trying to do a forecast like what we did in regression analysis under this session. Rather, for an already existing absolute values, we are going to assign a scaled value so that you can see the relative movement when you look at a number. For instance, let's say there's a basket of goods which has weight of 45,000, for instance, and the next month it has gone to 45,335. Okay, so you might not really see the movement of that 435 in compared with the that 42,000 odd number. Rather, if you just compare a number like, okay, it was 102% last month, it has gone to 104.1% this month. So you may easily understand, okay, it seems to be approximately 2.1% increase from percentage point of view. So indexing is all about trying to represent the data set in a different scale and track the movement for you to take effective decision making. So taking the beginning like that, let's move on to theoretical area what we are going to discuss under this session. Okay, this is the plan for the day. We will be discussing an introduction into indices. We will discuss the characteristics of indices, the importances. These are all theoretical aspects. And then under section 4 and 5, we will learn two main methods that are being used to construct indices, where we call them Laplace and the Paasche methods. So under that, we will learn how to do the indexing in a very basic sense. So then section 6, 5 and 6, again we will be discussing some of the factors to be careful when we are constructing indices and some of the practical issues when we are trying to do a perfect indexing. 7 and 8 areas are some most commonly used usages of indexes, where we are going to discuss the real wages and GDP deflator. And section 9 is also very important. There we are going to discuss, once we do an indexing, what if we are going to change the starting point or the base year, we call it as that. So with that plan in mind, let's start our discussion on indexing. Okay, right. So the broader meaning of an index is a very simple thing. It is a measure of change of a variable over time. So when I use the word variable, the word itself has a meaning of it is going to change or it is going to vary from one point to the next point. The important measure to understand under the indexing is that we are looking at the change of a particular variable over time. So probably we are discussing week on week change, month on month change, yearly change. So where we are looking at the weight or the value of one basket of a certain set of items with the next point. Let's say t plus 1 year, t plus 2 year, what has happened to that. So that's the broader idea of an index. It's not a hard definition. We just have to understand that it is going to measure the change of a particular variable over time. So you don't necessarily have to put multiple items in a basket. Rather, your basket may even consider one value. So that's perfectly fine. So we can express an index as a ratio or a percentage. So the broader idea is that we are going to start an index with a point of 100 kind of a value, and then we are going to move that, let's say 100 if I start with, we're going to move that 100 to different points, say 102, 103. It may come down to 98, it may go down to, let's say 95, then again it goes up. So likewise, so the weight or the value of the basket of items that we are going to consider is going to be the determining factor of the value of the index. So let's look at some of the practical examples. Look at the first example. An economic index can represent the price level of a basket of goods and services. So a good index that we are going to discuss under this section shall be, let's say, the movement of inflation, for instance. So we have a basket of goods and services. So let's say, for the comparison's sake, let's just forget the services and let's try to take some basket of goods. Okay, we will have some vegetables, fruits, some gas, rice, um, some consumables like toothpaste and soap at one particular point, let's say uh, at the beginning of 2020. And the value of the same basket we are going to measure in the next point. Let's say the next point I'm going to define as 2021. So the weight that we are going to assign for 2020 shall be the uh, individual items that we are going to assign for that basket and the number of items. For instance, from vegetables, I will select, let's say only one vegetables, potatoes. I'm going to select 5 kilograms as the starting point. And per kilogram price would be, let's say, 100 rupees. And for the next point, then I'm going to move from 20 kilograms with 100 rupees per kilogram. Then at the next point, I'm going to define, okay, my consumption is not 20 kilograms anymore. It has changed to 25 kilograms. And the price also from 100 rupees, it has gone to, let's say, 120 rupees. And similarly, similar to that potato example, all the other items in the basket, so we are going to reconsider the weights and the prices. So when you do a summation of the values that is in that small basket of goods under this index of inflation, you will get a number, let's say 45,000 for 2020 beginning. And the same computation, if you do for the 2021, you will get another value, let's say 46,000. So the whole idea of this weight that you are going to define from point 1 to the point 2 is that we are going to give a value to 2020 weight, and the same scaled value we are going to apply for the 2021 value. Let's say I'm going to start this entire exercise with the beginning of 2020. So whatever the weight or the amount that I'm going to get in 2020 shall be 100. I'm going to assign that value to be 100. So it's very easy. If 45,000 is 100, then all what we are doing is that we are moving this 45,000 value to 46,000. That means from 100 to 46,000 divided by 45,000, we may get an approximate number like 101.7. So that's the movement of economic index that you could see under a discussion like inflation. Okay. Another example would be a capital market index. A capital market index can represent the price levels of securities of a given set of securities. Look at this example picture that I've depicted here. This is the value that has been quoted at 2020 May 19th at 3:22 p.m. The ASPI, the green number here, stands for All Share Price Index, and the other one, S&P SL20, stands for Standards and Poor's SL20 Index. Now, what are these numbers? Look at this 4,701.03. Now, that's the value equivalent to that 42,000 and 45,000 example that we discussed. So, for this All Share Price Index, there seems to be some set of securities that has been allocated for the basket to be considered under the All Share Price Index. So the value of that basket on 2020 May 19th is equivalent to 4,701.03. Now if you look at the index point of view, we're looking at 94.18. Now, these all share price index I've taken from the Colombo Stock Exchange website. This 2.04% is the change from the previous day to the current day. The similar explanation is there for the S&P SL20. The only difference in these two indices is that all share price index comprises of all the securities and SL20 index comprises of only 20 highly liquid securities. So the mere example that I'm trying to bring here is that it doesn't necessarily need to be from year one to year two. Rather, every second, every minute, if you have data, you could do the same calculation for the index. So the securities market index is a very good example where you have even millisecond movements of index movements from one point to the other millisecond. So all what these indices are doing is that, again, I reiterate, it measures the weight and the change of weight from one point to the other. It is going to represent from a percentage point of view for the easiest comparison purposes. Okay, let's look at some of the characteristics of an index for you to understand what these are. An index can measure the variability of a given phenomenon. So let's say now that examples that we discussed comprises of price indices, inflation indices. Similarly, I mean, you can define any phenomena into a basket or a set, then measure the weight as per the weighting that you're going to assign for that basket. So it doesn't necessarily have to be tangible things always. Let's say, I mean, if you want to put up some weather related matrices into one basket, and you can even create an index. Let's say you want to put some energy related items to a basket, you can create an index. If you just think of, let's say, a practical example like kerosene, petrol and diesel consumption in a country like Sri Lanka, say what you have to do is that you define your basket as per the consumption at the point that you are defining. In the basket of your definition, you're going to say, let's say I'm going to put 2 liters of petrol, 3 liters of diesel, and half a liter of kerosene. Then you have to have a scientific method to define those weights also. That's very important. And then from that point to the next point, you're going to again reassess the weighting that you're going to give for these 3 items in your basket. So it's obvious that you have a price point in the first point as well as the price point in the second point. So all what you're doing is that you are creating an index as per the wish of your desire. So this given phenomenon can be a tangible, intangible, your custom defined or a standard one. Any phenomenon, the variability is the measure that we are going to measure from an index. Second point. An index can measure the variability of a given incidence's movement over a time period. So this is also one very important thing we discussed since inception. We the x-axis or the variable that we are going to look at for the movability, that is time period. So the time period could be, as we discussed under securities indices, it could be even minutes and seconds. Rather, in some practical senses, it could be from 1 year or 1 month kind of a moment. So if your frequency of change is very rapid for that given phenomenon's variable, your time period could be low to represent the micro movements. But if your focus is towards much more macro kind of a picture, you can always select a higher number of time periods like months and years. Third point, an index movement can be explained as a percentage. That's what we discussed a moment ago. Why do we come to the percentage? Is that it's very easy to compare the percentage numbers compared with the absolute numbers. So these are the very basic 3 characteristics of an index that we are going to keep in mind. I repeat, it is going to measure the variability. It can measure the variability over time, and we are going to express the index as a percentage for easy comparison purposes. Look at this example that we have put up here. It says quantities bought in the base year. So we have 150 cup of coffees, 20 PCs, 12 insurance payment, and 10 pairs of jeans. Now these are different uh, items: coffees, computers, insurance payments, and jeans. What are they? They are expenses. So it seems to be, let's say, a household set of expenses, or a company's point of view of expenses. It could be anything. So the first one, what we see here is the price in the base year. So we are defining this base year and the in the upcoming sessions. Just for the time being, let's say this is the starting point, the base year, and then we have the price after 1 year. Then we have the same after 2 years. So what we have here is the quantities: 150 cups, 20 pieces, 12 insurance payments, and 10 pairs of jeans. These are the quantities that we are going to measure for this particular index that we are going to construct. When we have the prices, let's say a cup of coffee is $4 and it has moved to $4.1 and it has moved to $4.2. Similarly, all the other items also, we have the price per unit in these columns. When you're going to construct an index, what we have to do is we have to simply take the multiplication of the price and the quantity, provided that we are looking at a basket. So the 600 is nothing but 150 into 4. 400 into 20 is 8,000. 80 into 12, 960, so on and so forth. Then we have to take the total number of value under this particular basket of 4 items. So for the base year, for the starting point, we get this as 10,160. Importantly, under the indexing, what we are doing all is that for the starting point, we are going to give the index value as 100 or 100%. So technically, we are going to equate this 10,160 into 100. Simple as that. We don't have to do any more math, just that 10,160 shall be equal to 100 is our starting point. Okay. Then we move on to the second year. Look at what has happened to the prices. Now the quantities under this example, we are going to keep it as unchanged. Okay. So for the same set of items, now look at the prices. Prices have changed from $4 to $4.1. This 20 pieces, $400 to $410. 80 to 85 and 60 to 62. Now what will happen is that the simple terms, instead of these total values that we computed under the second column, the fourth column you are looking at will have different values. Why do we get those different values? That because of the difference of prices. Now look at the total. We had 10,160 and the total after 1 year has changed to 10,455. Now to get this 102.9 is that you take your calculator and try to do this division. 10,455 divided by 10,160. Let me quickly get my calculator also. So we have 10,455 divided by 10,160. And then do a multiplication of 100. You multiply the value by 100. So there you see we are getting the value of 102.9035. For the first decimal point, we can define this index point as 102.9. Now this is a very primitive point of indexing. So I mean, technically what we have done is that under this table, we have calculated the movement of inflation for a defined set of basket of 4 items from year 1 to year 2. We assume the consumption has not changed from year 1 to year 2. Rather, the prices obviously will get differ from one point to the other, and accordingly, your index value shall be a different value from 100. But if you get 10,160 here, so technically the index value will be unchanged. The same index point of 100 shall be moving to the year 1 as well. So year 1 index value is, sorry, the base year index value is 100, year 1 index value also 100. So next year you may see a difference. Similarly, year 2 also, you have different points of prices. You will have a different cost of cost of market basket, and accordingly your index value will again be a different number. This 105.4 is the comparison of 10,704 to 10,160. So this 105.4 is the new index value now. So this inflation rate is the comparison of year 2 to year 1. So this is a very simple exercise of how we define an index from a set of basket of items. So having identified the characteristics of an index, let's try to move on to understand why we are going to do this indexing and what's the importance of doing an indexing and what are the usages. One could say, okay, indexing seems to be an extra step from absolute world and defining things in a different scale. Absolutely correct. That's fine. But the whole idea of indexing is that rather we discuss the changes of absolute numbers in thousands and millions, if we just boil them down to a scale of 100, the movement or the percentage movement is very easy for even a layman eye to understand what sort of a change or the variability has been happened from one point to the other. These are some of the importance of indices. First point, indices gives a good basis for comparison. Now, what do you mean by this comparison? All why we are doing the indexing is that we are trying to understand the variability of a phenomenon. So what if we want to do this comparison over multiple periods of time in multiple geographies? So isn't it going to be easy if you scale down everything to 100 and equivalent? That's the whole idea of this good basis of comparison. So once you boil them down to a uniform basis of hundreds for a comparison purpose, it's very easy to discuss and it's very easy for the eye to understand where your index value has gone up and where your index value has gone down. Yeah, there's a question. In our previous discussion, when we are calculating the index for the year 2, whether year 1 will be the base value or the base year. It's not the case. Always, let me scroll down to my slides again. Once you define the base year, it's very important to understand that until the base year has not been redefined, we are always comparing the movement of this basket from year, base year point of view. So this question is about when we are moving from year 2 to year 1, we are going to consider year 1 as the base year. It's not the case. Rather, we always come to the base year, look at the base year's value 10,160, and then we look at the current year's value 10,704. So this will be the comparison when we are going to do the price index point to point change. Okay. I mean, just looking at the inflation rate that you are compared here in this table, it's not the case. Inflation is a measure that we are going to uh, compare the change from one year to the next year. So that might be the confusion you are facing here. But merely coming back to the argument on the base year, up until you redefine the base year, you're always comparing the weight from the current year to the original base year. Okay, right. Coming back to the importances, uh, so it's a good basis of comparison without any doubt. Second point, they are assisting in policy making in both economic and business activities. So let's say nowadays, if you look at some of the important indices, you may discuss what has happened to inflation in Sri Lanka. You may discuss, okay, with these changes in geopolitical situation, economics, new appointments into political arena, uh, changes with the health and safety conditions in different countries, you may see the values of different variables moving sideways. Sometimes it could crash, some indices will go up. You may discuss gold prices has gone up extensively. You may discuss some of the countries are interested to deposit their wealth in gold. They are selling their assets from emerging economies and they are going to park their money in different safe havens. So when you discuss all these factors, the gold prices, the stock market movements, the inflation movements, all what we are comparing is nothing but the value of these indices. Bear in mind. We're not going to discuss the absolute value of gold, rather we are going to just discuss, okay, gold prices has surged from 5%, 7% from beginning of year point of view, from year on year point of view. So uh, when you look at a value like that, it gives an indication for the policymakers, okay, it's time to change the policy. So it's time to go for an adaptive policy, a controlled policy, uh, some sort of damage controlling kind of a policy. So all again and again, I reiterate, rather if you want to discuss the price of gold with an absolute dollar point of view, one may say, okay, gold price was $20,000 last year and it has moved to $21,170. So for the human brain, it's pretty complicated to understand that 100 and 1,000 some sort of a change with the 20,000. Rather, if it means just presented with 3% surge or a 5% dip, it's very easy to understand for policy making in many domains, especially in economic and finances numbers. Okay, the third point, indices can be useful in measuring the general trend of a given phenomenon. Let's say you measure the all share price index for 10 years, and from year on year you plot 10 data points. The general trend, let's say, if you don't have this corona incidents and if you don't have any major changes in the political or geopolitical economics, so you may not see much of a difference. So you may just see a nice trend of upward or a downward trajectory depending on the company's earnings. So for a given different time period, let's say 5 years or 10 years, indices can be very useful to understand the general trend, whether you are seeing an upward trend or a downward trend. It's like similar to what we discussed on the regression. You plot these different points and do a best fitting line and see what sort of an upward or a downward trend that we are looking at. Fourth point, index numbers are useful in deflating. For example, they can be used to adjust the original data, price changes, to adjust wages for cost of living, etc. So the point 4, it says when you are using the index numbers for decision making, the most commonly used instance would be to do adjustment to various variables. For instance, let's say some of the salary slips. If you look at salaried employees, you may see a cost of living allowance. So the cost of living should be a variable that is measured by inflation affiliated uh, equation. So when you do the cost of living adjustment for a salary slip, what we are seeing is that from uh, point 1 to the next point, there should be an index, and with that index, you're going to deflate the value for the year 1 from the year 1 to year 2 kind of a movement. So when you want to look at a deflator, what you are looking at is a general trend. And then obviously in decision making, if you want to do an ex ante or an expo, that means whether an event has happened or whether the event is about to happen. If the event has happened, you could do a simple average and do a calculation. And if an event is yet to happen, like a discussion on the regression, you could uh, you could plot a best fitting line, look at the general trend, and define the next point of interest for this particular index to be. So again, the point what we are going to stress here is that for the real world variables, by using an index, we are going to adjust or amend the data point for us to make decisions, pay wages, do computations like that. Fifth point, indices can be helpful in comparing the purchasing power of different countries. Now, this is a very important point. Now, certain countries, if you look at their demographies, they may not have the same currency, they may not have the same style or type of economy. Some will be socialist, some will be democratic. So looking at the currencies and looking at the types of whether it's a net import or an exporter, you may see different values of GDP, different values of production and imports and export of different countries. When you look at all these factors, it's very different to compare whether a country is stronger or powerful compared to another country. So one of the easiest ways to overcome that comparison problem is to use an index. So for instance, let's say we take an index like GDP growth. You may see emerging economies have a GDP growth uh, maybe 3 to 5%, and a stable economies will have a slightly lower compared to emerging economies. So based on the GDP growth, you may have seen different indices of, let's say, price movements, foreign currency exchange rates, and those indices will obviously tell you whether a country's currency will see a deflating or diminishing trend or an appreciating trend. So, by using concepts like purchasing power parity, using the inflation and exchange rates, you may be able to do a nice comparison for the purchasing powers of different countries. So, what's the underlier that is going to help for this computation? Again, nothing but indices of different countries. Last point, index numbers of business activities can highlight the economic growth level of, again, different countries. So let's say, to get some examples of business activities, we're looking at, let's say, for a given economy's price to earning ratio or a dividend yield ratio, dividend payout ratio for a given economy, a complete set of securities if you put up into one basket and see whether your country's stocks are growing or whether your country's stocks are stagnated or at a diminishing trend. I reiterate all these 5 to 6 points. What is the essence that we are trying to communicate here is that nothing but these points. Indices gives a very stronger and a easier way to do comparison. Sometimes indices can be very helpful in defining or deflating or inflating certain numbers for you to take the decisions. For it could be for a known set of variables, it could be for an next point using a known set of variables also. Again, indices will give you the trends, indices will give you the comparison basis of different countries, different currencies, different businesses, so that you should be able to understand which is better and which is worse. So that's the importance of indices, what we could identify. Moving on, now comes the interesting part. Now we are going to do some index computations. Okay, we are going to discuss two methods, Laspeyres and partial method, to do this index computation. Now, the very first discussion that we had under this inflation computation, there we assume that the quantities shall remain same, and we just discussed the price changes, and we identified that okay, when the prices are getting changed, your basket's weight or the value is going to change. And easy, you define the year one as the base year, and with the comparison, you move on to the next couple of years, and then you measure the change of the index. So the last pairs and partial method are some most commonly used methods where it could cater both changes in prices and quantities of your basket of consideration. Both have a similar method of calculation, rather a minor difference into whether you're looking at the base year's prices and quantities or the current year's prices and quantities. Okay. So both these methods are coming under the umbrella of weighted index numbers. So this weighted index numbers method is going to assign weights for relative importance of each item in a basket. So these quantities, these Qs, are the method that how you're going to assign the weights for the basket from time to time. Let's look at the equation first, and we will do a computation and see how this Laspeyres method is used in index computation. If we look at the Laspeyres method's index value for a particular given year, this is what we are doing. We are taking the sum product of different prices and quantities of number of items in a given year, and divide by the same in the base year or the starting year's sum product of the prices and quantities. So the difference from these two P0, Q0 and Pn and Q0 is the Pn and P0 if you look at carefully. Let's see what these P's, Q0s and N's are. P is nothing but the price of the goods or services. Q is the quantity. So this O is the base year or the starting year, and N is the current year that we are going to consider for this index construction. So if I read these items, Pn means the price of the goods in the current year. Q0 means quantity of the goods in the base year, not the current year. Okay, see, 0 or O stands for the base year. Go to the denominator. P0 is the price of items in the base year. Q0 is the quantity of items in the base year. So under the Laspeyres method, what we are doing is that we are going to consider the start year and base year and compute these values, and accordingly we shall be able to get the index value or the index number for the year under consideration. Without further ado, let's look into one of the working examples. Right. What you have to do is to calculate the last price index using the year 2012 as the base year. Now let's look at these items and let's see what they are. I'll use the board here. Right. Yeah. So we have the items of five different types of commodities. I have rice, I have sugar, chili, flour, and coconut. And in the measures of these items are also given in kilograms, and coconut oil in liters. So in 2012, this basket, you have the prices of items per kilogram and per liter, and also the quantities of items in quantiles or numbers, units. So 2012 to 2016, if you look at carefully, now we have both changes in prices and we have changes in quantities as well. The prices you can understand. Price obviously from one point to the other point, it will change. What about quantities? This is a rebalancing. So in 2012, this basket will comprise of 40 kilograms of rice. In 2016, let's say we're looking at a consumption kind of a basket to be defined. In 2016, what has happened is that now the person who is defining this basket, he has defined, okay, it's no longer 40 kilos. Now it has moved from 40 to 35 kilos. So similarly, rice, sugar, if you look at all the other items, you may see the price changes and as well as the quantity changes. So the last pairs method we discussed. Under last price method, what we are doing is we have to take the price and quantities of the year under consideration and base year, compare the same with the price and quantities of the base year. So for us to compute these values, in simple terms, what we could do is that we could draw a small table. Now the question says, calculate the last price index using year 2012 as the base year. So year 2012, whatever the value that I'm going to get here shall be the base or the 100 equivalent value. So what we are going to do is that we are going to find the 100 equivalent value for 2016, right? We'll just plot this data in a small table and see. I have the P0, that is going to be the 2012 prices. That shall be 70, 80, 120, 80, and 150. So these are the 5 items under consideration. Then I have the quantities defined for 0 point, that is year 2012. It's 2012. So it's 2012. What are those quantities? I have 40 here, 8, 1, 3, and 3. 48, 1, 3, and 3. Right. We can do a simple multiplication and calculate the P0, Q0, isn't that so? It's nothing but a simple multiplication. You'll get 2800 here, 640, 120, 240, and 450 here. Then what you have to do is that you can take the sigma of these points. Should be getting a value close to 4250. What we have calculated here is the sigma P0 Q0. That's the denominator part of the last place equation. Next point. We have to calculate the Pn Q0. Do we have the Pn? Yes, we do. We have the prices of year 2016. We write those points. Pn 2016. I have the prices of change numbers to 85, 100, 150, 110 and 200. Okay, 85, 100, 150, 110 and 200. I have the Pn and I have the Q0. So the simple multiplication with these two, I can calculate the Pn Q0. 40 into 85 should get somewhere around 3,400, 800 here, 150, 330 and 600. Right. Similarly, P0, Q0, now I have computed Pn and Q0. The total, again, the sigma shall be 5,280. What I have calculated here, this is the P0, Q0 sigma. I calculated here Pn Q0 sigma. So the last Pairs index says take the sigma Pn Q0 divided by sigma P0 Q0. I have these values 5,280 divided by 2,250. Now this should give me a value close to 1.2423. For the comparison sake, let's say I am going to say this P0, Q0, this as the year 0. If this is going to be 100 for year 0, then I can multiply the same by 100, so that for 2016 also I am going to get 100 equivalent value. This is 124.23. I repeat, I had the prices of 2012 and I had the prices of 2016. Under the last price method, we don't change the quantity, rather we take the quantity of the base year 2012. And the change, what we are going to consider would be the sum product of the price to year 0 and price to current year. So from a mathematical point of view, this is nothing but a simple multiplication and taking the sigma for the computation. Okay. So the answer for that question shall be calculate the last price index using 2012 as the base year for year 2016. So for the year 2016, your last price index should be equal to 124.24. That's about the last price method. The second method to compute the index using this weighted index numbers method is the Paasche method. So if you just look at the two equations of last pairs and Paasche, the sum product and the sigmas and the multiplication of hundreds is all same. If you carefully look at the factor that you are changing, earlier under the last pairs method, we kept the quantities of year 0 as constant, and then we looked into the changes of prices from year 0 to the point of interest in the previous example from 2012 to 2016. Under the Paasche method, we are forgetting the quantity which were there in the base year. That means simply this Q0 is no longer there. Rather, we're just taking the Qn here. Qn is the most current year's quantity. So the earlier example, if you look at these quantities of 40, 80, 1, 3, and 3, these are no longer valid for partial method. Rather, it will take the most concurrent, the most available uh, point or your point of interest, Qn, to be the current year's quantities, and then do the sum product for the uh, prices of year 0 and year 1 of your interest. Look at this text. Partial method use quantities of the current year to compute the index in comparison to the base year quantities used by the last payers. So both methods have a very similar method of calculation and exact same steps to be also followed. The only difference is that what you have to keep in mind, for the last payers method, you keep the quantities of the base year constant. For the partial method, forget the quantities in the base year, rather you take the quantities of your year of interest or the most recent year, assuming that it is your year of interest, and do the sum product for the prices difference from year 0 to year n. For the same example that we had here for year 2012 and 2016, let's do the same index computation using the partial method for you to get a grip. Okay. So I have the P0 here, and instead of Q0, now do I need the Q0 anymore under the last pairs method? Of course, yes, I need the Q0, but for the partial method, you don't need the quantities in the base year, rather you're going to use the quantities of your year of interest. So for the previous sum, 2016, let's take the n as 16 and Qn I'm going to define for 2016. Okay. Quantities in 2016, I had 35 and 6 here, 1, 2, and 2. Right. So similar to P0 and Q0 previously, now we are going to compute P0 into Qn. So these values shall be 70 into 35, 2450. This is 480, 120, 160, and 300. So I have the P0 Qn multiplication here. If you take the sigma, it should be equal to 3510. Okay. Right. So I have the P0 Qn. So Qn is constant. Now what I need is Pn. Okay. That is already there in this column. That is the most current or the year of interest values. And I can compute the P0 Qn. Yeah. Sorry. P0 is here. Pn is here. So that I can compute the. Sorry. Let's see that. I have the Qn here. I have the Pn here of year 2016. What I'm going to compute is the weight of the most current point Pn Qn. This is for 2016. 35 into 85 should get 2975. This is 600. This is 150. 220 and 200. Yeah, 52. The sigma of this part shall be 4345. Okay, I have all the ingredients for the partial methods now. Under partial method, what I have to do is take the sigma Pn Qn that is the year 2016, my point of interest versus sigma P0 Qn. So the Qn remain constant, and we did the comparison for P0 and Pn for these 2 points. So again, I have to take the division of 4,345 divided by 3,510 multiplied by 100 for a 100 equivalent comparison base. And you should get a value close to 123.79. This is the same computation if you use the partial method to calculate the index point of year 2016, assuming year 2012 is going to be your base year. Okay. So there's no right and wrong here. There's no one method is a superior method compared to other method, but both are different methods of comparing the index point. So indexing is also nothing but a comparison, isn't that so? So we have a base year weights, and then we have the most current year for the point of interest years weights. We do a comparison. In one method, last pairs method, we kept the quantities of year 0 constant. Under the partial method, we kept the quantities of your point of interest as constant, and we did the sum product for 2 different methods. Okay. Let's do a little bit of a comparison of these 2 methods and see what the merits and demerits of each of these methods are. Okay. First point, last pairs methods is going to assign weights on the base year and hence less costly to calculate. What does it say? Last pairs method attempt to assign weights on the base year and hence less costly to calculate. So the weighting under the last pairs method is calculated for the constant set of quantities that is defined at the year 0. So let's say price change, it's pretty easy to find, isn't that so? Different price points of oil, coconut, vegetables, fruits, you may be easily able to find the prices. They have multiple sources. They have multiple points to publish. What are the quantities? So if you're merely looking at an index like inflation, you have to be really careful on the defining of these weights. At the first point, at the 0 point, T0, Q0 point, somebody must have done a survey and defined, okay, these are the Qs, or these are the quantities that you're going to use for this particular family or this household, this company, anything. So that quantity is kept constant is going to ease your computation you're using the last pairs methods, because from time to time your consumption is going to change, obviously. So let's say if we discuss extensively on inflation, let's say a family will consume 50 kilos of rice for a given year. Hypothetically, let's assume 50. So the next year, there is a chance that the 50 kilos shall remain same. But due to various different factors like prices of rice, availability, substitutes, different types of products, different revolutions been happening in the food industry, your rice consumption may not be 50 years in the next year. Maybe 49 or 48 or maybe 52, 50. It could be anything. Depending whether you are facing a lockdown scenario, you may have to consume a little bit more rice compared to the normal instances. So obviously your quantities is going to change. However, that measurement, that second measurement of quantity change is going to cost you another survey to do the comparison from year 1 to year 2. But provided we are using the last pairs methods, your initial survey is the only survey that is going to consume your time and effort for the computation purposes, and then you compute the uh, next points using the last best methods by only looking at the price changes of the respective years. That's the first point of comparison of last best and partial. Again, it moves on to the second point. Last best methods has a common denominator, and hence it is easy to compare index points over time. Now, if you look at the last best and partial, uh, if you categorically look at the partial index, your denominator, let me just scroll to that slide. Yeah, this one. This denominator Qn is going to change from year to year in a practical scenario. Isn't that so? So the quantity that you're going to consume under this basket for this year is not going to be the same for the next year. So obviously under partial method, your denominator is going to have different value. Look at the partial method. This P0 and Q0 for the base year, once you define it, it is going to be a constant, isn't that so? I mean, look at the price. Those are the historical prices of the base year that you define. The quantities, again, the quantities that you define in the base year. So when you compute the last payers methods base year towards the next couple of years, do you going to change this base? No, denominator is going to kept unchanged. Partial method, your denominator is going to change from one point to the next point, depending on the quantity that you are referring at that particular point. That's what this point is trying to say. Last payers methods has a common denominator, and hence it is easy to compare the index points over time. So from comparison point of view, if you lock your price and quantity at the initial point, the comparison is going to be very easy because you're comparing always from a constant denominator to the next moments of your time or the yearly spans. Right. Third point. However, partial method is using updated information for weighting, I mean the quantities, and accordingly, that index represent more realistic situation. Now that's the true point under the partial. Although it is costly, although it is very difficult to compute, and although your denominator is going to change from time to time, partial methods gives a much more reliable representation of the current situation or the more realistic situation when you really do the computation. I mean, if you look at the partial methods computation, what it all does is that for the quantity that you're consuming right now, for that quantity, you are doing the sum product for the prices of the historical of, and the prices of the most concurrent, and do the math to get the partial index point. Those are the 3 points that we can compare for the last pairs and partial. Okay. So again, I reiterate, there is nothing to be considered as what is the best and what is the uh, worst. Rather, these are two different types of index calculation methods, and these are the comparison under these two different methods that we can discuss. Okay, let's move on. Under fifth area, we are going to consider the factors to be considered in preparing the indices. Now, these are your decisions that you have to make when you are defining an index. So all this time we are using an index defined by somebody, but if you've been given a task to define an index, this is what you have to do. First one, base year should be a reasonable year and should not be a very old year. What does this trying to say? So let's say for an instance, like GDP growth or inflation, you may select a very old year like 1980 or 1990 or year 2000 as a base year, and different rebasing will always adjust your index values over a period of time. But if you have been given a chance to do a computation, you have to make sure that unless otherwise you are computing a very prolonged series of data, unless otherwise you're doing that, you always have to select a reasonable year. Let's say 5 years down the line or 10 years down the line. Let's start that point as the zero, and let's look at the construction of the weight of the basket from that point to the most current point. So unless you really want to go for an old year, you have to always make sure that you have to select a reasonable year. Second point, basket of items should be carefully selected to represent a true and a fair usage of items in the phenomena under consideration. This is the very trivial point in any index computation. So the pricing, I reiterate, the pricing is something which you cannot change. Why? A price always comes from an equilibrium between price and a demand in an economic point of view. So unless you have a controlled scenario with a cap or a floor or with a controlled prices, you're looking at a normal good. You're always looking at a competitive market and looking at the prices being moving freely without any influence. But the quantities for your index, you have the privilege and you have the free will to determine the number of items that you're going to put for this particular basket. Now, that has to be a scientific method. I mean, you should not use the indexing to manipulate a certain set of data and do a injusticeful representation. The indexing has to be always carefully selecting the true and fair representation of consumption. That's the most important point. If we discuss a little further, let's say you're trying to measure inflation using your own index. Forget about the official indices. You're trying to measure the inflation of a given country. You define the consumption of items. Let's say for a month, you're going to define for a family of four, two adults and two children. Okay, that's your sample or the phenomena that you're going to consider. You determine based on the statistical mean data, determine an average family will have two adults and two children under the age of 18 for a given family. You define that first. For that family, you're going to define the usage of food items in a given month. Forget about the rest of items like fuel, kerosene, uh, gas. Let's forget about those items and just focus on the consumption of food items. Okay? Um, Now, for you to determine whether how much kilograms of rice that you're going to consume for that family, what's the obvious thing that you have to do? You have to do a sample survey. You can't reach the entire population. You have to do a sampling survey and find average number of kilograms that you are using. Obviously, you will interview a couple of families. You will go to them and ask, okay, for a given month, how many times that you go to the market and how many kilograms of rice that you're buying. You may get different answers. And like in any sampling discussion that we had previously, you could do a justified sampling computation and find you are going to determine that this family, that average family or the representative family is consuming 4.5 kilos of rice for a given month. Hypothetically, let's assume that case. Similarly for dal, similarly for vegetables, fruits, and other items like butter, coconut oil, sugar, you define the same weights. Now, from the definition of consumption, when you go to the next point, you can't blindly apply the price changes and look for whether your quantities assumed to be remain same. Rather, the similar exercise has to be done for the second point as well, and for the third point as well, and for the fourth point as well. That means the consumption could change from one point to the other as we discussed in the previous point. So as long as you don't represent the true consumption of items, what you're doing is you're computing an index with an unfair representation of consumption. So this is a very important point. If at all you're defining an index, make sure your consumption of basket of goods or services has to be true and fair. If you put up items that they're not consuming, it's not a good representation. If you change the weight in an unreasonable manner, it's not a good representation. If you don't capture the entire set of items that they're consuming, that is also not a good representation. So you have to have from one point to the other point a fair representation. That's about it. Third point. Waiting should represent actual usage and swiftly reassets. In fact, it's more or less the extension of the second point that we discussed. So, actual usage is the important point. You may get interviews of that rice example 4.7 kilos, 5.2 kilos, 4.1 kilos, and you put them up in a nice standard normal distribution and find the mean. You take a three standard deviation kind of range and you define your mean to be 4.7 kilos. Now that should be an actual usage. You make sure that at least 68% or at least 95% of your population falls into that actual usage point. And again, from point to point, you have to do a reassessment. Final point is that similar to the weighted method that we discussed, Lasper's and Pache, you have to do a calculation method selection. These are the not only two methods that is used in the statistical world, there are plenty of other methods. So should you given a choice, you have to select a calculation method based on a logic that you are defining. So these are the important points to be considered if you are preparing a fresh index, right? So these are some of the issues that you will come across if you are preparing an index, right? It is also coming from the same points that we discussed for the construction or the consideration of indexes, right? We'll go a little faster. Accuracy of the data collected can cause disturbances. Now, if you look at computation like inflation, how do you think in Sri Lanka do they do? As far as what I've heard is that they use some agents from the Department of Census and Statistics, licensed agents. It could be government employees, it could be some other parties, for them to explore the price changes from one point to the other point by using a set of tables and by accessing the points of these prices are being published, like supermarkets, it could be like different markets, places, it could be some retail shops, it could be some wholesale shops. So they have to visit these different places, they have to get the prices and report it back to the Department of Census and Statistics in Sri Lanka. So once they get all this data, they have to do a filtration and make sure that the data that they get are very accurate. But provided, now that's a practical example. But provided, let's say you are doing an indexing and you are going to collect some data. Let's assume that you have a doubt of the accuracy of the data is being collected. Now that is obviously going to cause some disturbances. So instead of in our examples like these price points of 85 and 150, let's say the true price is not 150, rather it's 110. Now that is going to change the index at least a couple of basis points or a complete index point. So obviously, data quality is the most trivial issue in any index preparation instance. Second point, difficulty in selecting a base year. Now, this is an interesting point. Say, how do you do the selection? Whether you're looking at year 2000 to be the century defining point, or every 10th year you're going to do a rebasing, or you're going to select from current point minus 10 years. It's up to the decider, it's up to the selector. However, it is going to be a difficult task because depending on the starting point of your weight of the basket, you may change the landscape of the index. That point is very important. You may change the landscape of the index that you're going to define. Let's say, for instance, in a practical example, let's say for a stock market index, you are going to select year 2008 as a base year. What happened in 2008? Due to the post-war peace situation in Sri Lanka, stock market has strike to a very uprising point, and the indexes of both all share price index and self-made index skyrocketed to very all-time high levels. Now let's say that is year 2008. Okay. Now today is year 2020. Now I'm going to select year 2008 as a base year for a custom stock index that I'm going to build. What will happen? That was the all-time high point. From that point, if I just select it as the base year, all what will happen is that from that point, I may see a downward trajectory point. What if instead of year 2008, I select, let's say year 2000? Year 2000 is a neutral point. We did not expect much of a dramatic change like a geopolitical change in a country. It was just a casual year, if I could recall. So instead of year 2008, if I just select year 2000 as my base year, that is going to give me a much more neutral picture for the index that I'm going to consider. So that difficulty of selecting base year is evident in any case. So I reiterate, if you want to window dress your index and to represent something in a biased way, obviously your base year selection is going to be very trivial. But that shouldn't be the case. That shouldn't be a good practice. Rather, a selecting of base year has to be a very neutral and a non-biased way so that your next index point is going to truly represent the movement of a yearly or monthly or a whatever the periodic movement that you're looking at. Okay. Third one, it does not focus on the quality of the items in a basket, rather price and quantity. Now, if you put up that rice example of 4.7 kilos, now rice itself has many sub varieties, isn't it? So you may see some families are using one type of rice, but some other families may using couple of types of rice in that 4.7 kilograms. Now, if you have to do a perfect justification, what you have to do is that you have to find under rice, there are different types of rices, and from different types of rices, they are going to consume this much of an average quantity in a given month. That is going to be very difficult. So rather, in any index computation, you have to do a bit of a generalization and select the quantities accordingly. So sometimes you may have to omit the fact of quality, rather focus on the type, rice, LP gas, oil, kind of a generalization and do the math. Rather, if you are going to go for the subtypes of available uh, items under one particular types of item, for instance, rice, it is going to be very impractical to do the computation. Right? Fourth, practical difficulties in gathering data on usage price due to issues as non-accessibility. Now that inflation example we discussed a moment ago, if you have to do a perfect inflation computation, you have to have thousands and hundreds of thousands of agents who have to go and collect the data in a very frequent manner. But sometimes in certain markets, like emerging economies especially, and certain situations like geographically dispersed locations, you may not be able to access the true data set for you to get a complete understanding on the price and quantity changes from one point to the other point. So there could be many practical difficulties like being not getting the correct prices, being not having the accessibility to the uh, uh, points of interest, being not disclosed. Like certain economies, they don't disclose their continuous data. Some economies in some countries are pretty much close to the outside world. So many difficulties shall be encountered in when you are trying to gather data. Last point, due to substitution effect, demand for items in the basket can be changed rapidly in certain instances. Now, certain times, now a good recent example would be this lockdown scenario that we all encountered. We had to substitute some of our consumption of food items if we categorically discuss. We earlier may have to consume some, sizable amount of flour-based items like, let's say, buns and bread and maybe string hoppers. However, due to the non-accessibility, due to items being not available for our disposal, we had to use substitutions like rice, obviously. So now that instance, we could understand that if you do a inflation calculation, your true consumption picture will not come into play. Why? Because due to certain instance, due to whatsoever circumstances, we the users or the consumers have substitute the items that is in the basket due to maybe due to their choices, maybe due to some unavoidable circumstances. So obviously, this substitution effect is very difficult to measure for a very shorter period, like even for a week, for a month in certain instances. So we will assume that in our base example, we will assume that 4.7 kilograms of rice for a family of two adults and two children is the standard usage. But they may have substituted the consumption of rice or flour-based items or to any of that with rice or maybe with some other food items where we are not in a practical instance to really go and assess whether they have actually consumed 4.7 average kilograms or not. So this substitution effect can also be a disturbing factor or a disturbing cause in preparing an index. So we assume that we are going to, or the users or the consumers is going to use X number of items. Rather, it will not be the case. They may have substituted that with some other items. So it's not a true representation, right? That's about the issues. Now let's discuss two more factors that shall be somewhat useful in indices related discussions, right? The first one is the real wage that is going to come as a result of the inflation of a particular country. In the text, we can calculate the real wage of a person by adjusting the nominal wage for inflation. So real wage is a determining factor of a purchasing power of a person. What does this say? So you may, let's say, a salaried employee, let's say in Sri Lanka, may get 100,000 rupees per month as his or her uh, nominal wage. But let's say that 100,000 for a period of 12 months is going to keep constant or more or less same. It could marginally go up and marginally go down due to various allowances and expenses. However, it should remain almost same to 100,000. Okay, but inflation data, if you look at in a monthly pattern, you may see different numbers for different months. So obviously, your nominal wage of 100,000 shall remain same, but your purchasing power from that 100,000 is going to get changed from 100,000 to plus or minus depending on the value what we get for inflation. If we get a deflating situation or a negative inflation, your real wage would be higher than the nominal wage that you're getting. But in a casual instance, in a normal economic situation, with an inflation being a positive number, obviously, your real wage is going to be lower than the nominal wage. Let's say, for an instance, your real wage is 100,000 and inflation is, sorry, nominal wage is 100,000 and inflation is 5%. Then, in that instance, we are looking at a real wage of 100,000 divided by 1 plus inflation is 5%, which shall give you a value of 95,238 as the real wage of a particular person in that month. Okay. Why this is important? Now, this indexing is an extension if you look at the inflation computation. In fact, inflation is a much more trivial use of indexing in real world situation, which is entangled with many multiple variables in a given economy, like our salaries, like our policy making, uh, defining different levels of caps and floors, import controls, export controls. So all this is will have some sort of a link to the inflation computation, similar to if you look at determining a purchasing power of a particular person or entity. This is the uh, argument between the real wage and the nominal wage. Similarly, one other factor that we can discuss is another practical implication. That is the GDP deflator. So GDP deflator, it measures the GDP change which has happened due to the change in price level, not the change in the efficiency, not the change in the level of technology, but only looking at the price differences. I repeat, measures the GDP change which has happened due to the change in the price levels. So even for the GDP deflator, let's say we take the base year as the 100. So from 100 point of view, we could do a computation and calculate the GDP deflator for a particular year. Let's just look at some practical example. I'm just going to give you some hypothetical set of data here. Right. So GDP deflator is nothing but the nominal GDP divided by the real GDP into 100. Right. So let's take a couple of years, 2015, 2000, 2015, 2016, 2017. I will take a couple of nominal GDP and real GDP values. Let's say I take for 2015 75,000 and 75,000 to be my base year of 100. And from this point onwards, I'm going to calculate the rest of the file. Let's say I put up 88,700 here and 85,000 here. And in 2017 also, I'll put up 101,600 and 88,000. Right. So assuming 2015 is going to be my base year. So for the next years, what I'm merely calculating is nothing but the nominal divided by the real GDP to be the GDP deflator for these different years of 16, 17, and so on and so forth. So 88,700 divided by 85,000, 101 divided by 88,000, sorry, yeah, 88,000. So all what I'm doing is taking some, let's say, just put some frictional values here. So now these are the values from a comparison point of view of 2015 to the next couple of points that I'm going to say, okay, the economy has inflated or deflated by 5%, by 14%, or by any other number compared to one base year that you're going to define. So similar to the previous discussion on wages, this is also another widely used discussion on index related computations. So these two aspects of real wages and nominal wages and nominal GDP and real GDP is some practical widely used instances of indexes. Right? Last point we want to touch upon for this session is the recalculating of a index provided that we have gone for a rebasing. That means previous base. Now in this previous GDP example, we put 2015 as the base year. Okay. So what if we down the line wants to change the base? Now, can that be a case? Obviously, it is going to be a case, isn't that so? So let's say I start an inflation index in year 1980. Now, after 20 years, obviously, I will find that, okay, I am comparing the 21st year data in compared with the 1980. So would that going to be a good comparison? We discuss under the factors to be considered for the you know, good indexes to be computed. Your base year has to be a reasonable year. So obviously, from time to time, any index will be going through a rebasing or change in the base year just to get an understanding of a good comparison with the very recent year's variables. So let's say all share price index, for instance, we may, yeah, I really can't remember the current base year, but we may be obviously looking at a base year, maybe like 10 years or 20 years to be a reasonable point. So 20 years ago, we had a value of 100 for that particular securities. Now it has gone to 3,000 or 4,000 or now. That means with that particular 100 point, your index has gone to 34 times fold or 45 times folds of a growth. So if a base year for an index has been changed or rebased, we can use the following equation to calculate the new value for each particular year. So what we'll be doing is that for a year under consideration, the existing base will give you a set of index value. Now look at this example. You have prices of rice. It's an index with a base year has to be defined as year 2000. So year 2000, what's the index value? It has to be 100. So in compared to year 2000, for year 2010, 11, 12, 13 and 14, you have got different index numbers: 180, 200, 225, 250 and 300. Now under the second table, what we have done is, now we have changed the previous base of year 2000. We have changed the base year as year 2005. Don't worry, we don't have the 2000 point, 2005 point, but just I'm trying to show you the different numbers that you are going to get. Okay. So obviously, when you change the base year from one point to the next point, what we are looking at is now your base or the 100 has changed. Now, previously for year 2005, under this old era, you may have had a value, let's say 115, Now that 115 is going to be your new 100. I repeat, now that 115 that you got under the previous base, year 2000 to be base, is going to be your new 100, right? So assuming now 2005 is equal to 100, now you have got already calculated values like 180, 200 using the previous year, previous base year assumption. Now for these individual points, this 180 is going to get a new value of 110 by using the equation depicted here. You're going to use the current year's old index value divide by the new base year's old index value. So let's say now this 180 is the current year's old index value. You're going to divide that by 115. That is what I said a moment ago. That is the base year's old index value. It's 200 divided by 115. It's 225 divided by 115. But let's try to walk through an example and see how your practical values are going to be. Now this is just a fictional table. All what I'm going to highlight is that once you change your base, obviously you're looking at a different set of indexes calculated based on your new base. Okay, so let me give you an example and try to see how do you use that equation. Right. Now for this example, I will give you for 5 years, year 2000, 2001, 2002 and 2003, 2004. Right. Now this particular index that you're going to consider will have the base year as year 2000 in the first instance. Now this is defined as 100. So in compared to this 100, now this rest of the years will get values of, let's say, 120, 150, 180 and 200. Okay, that's the starting point. Now what you are going to do is that instead of year 2000, you're going to define year 2002 as the new starting point of your index. Or year this 100 is no longer the base, rather this is going to be your new base year. Okay. Now what will happen to this new index? This is index old and this is going to be index new. Right. So instead of this 150, now this is going to be your new 100. Am I making sense here? Instead of this 150, this is going to be your new base year. Right. So once you have this value here, what do you have to do? Okay, now this is 100, it's clear. What about these other values? What are you going to do? Are you going to stay with these values and forget about these historical values and move on with the new values? No. You will have to do a complete rebasing and define the values under the previous indexing methods with the new indexing method. Okay. Now in a logical way, if you argue, let's say you are looking at values of x1, x2 and x3 and x4 for these unknown numbers. In a logical sense, if you argue, this ratio of 150 to 100 should be the same ratio between this 100 to x1. If I write it in a sense here, this ratio of 150 to 100 should be same to this ratio of this unknown value of x1 to 100. take a moment to absorb the logic. 150 to 100. Why this value of 150 I changed to 100? If that is the case, by same ratio, this x1 should be defined. So obviously, x1 should be, I'll write it here. X1 should be 100 multiplied by 100 divided by 150 or 66.77. This is how you get this value. It's a simple logic. Forget about the equation that which is depicted in the slides. But if you look at the mere math, what you're doing is that this same ratio you're going to compare with the new point with the old point. Let's see the second one. X2. Same logic. 150 to 100 should be equal to 120 to x1. Sorry, x2. This point is x2. Similarly, in that case, x2 should be 120 multiplied by 100 divided by 150. Should get a value close to 80. So similarly, you do the simple logical equation of this ratio being applied to all these values. You can calculate the new index to be replaced by these unknown variables like shown here. So if you take this year 2002 as the base year, so what you're looking at is year 2000 to be 66 under the new index, this to be 80, and this value should be 120 and 133.34 kind of values. So this is the rebasing of a particular year to a new year. I repeat, we had year 2000 as the base year, and we had some old index values, 100, 120, 150, 180, 200, by 100 here. This previous year, under this, we have defined year 2000 as the starting point. Later, we have redefined the base year of 2002 to be the new base year. So this value of 150 is going to be equal to 100 now. This 100 is coming here now. So if you have a ratio of 150 to 100, this is nothing but a 3 to 2 ratio. By the same ratio, your other value should always be represented. Look at this 66.77 and 100. It's another 3 to 2 ratio. Is that so? 3 to 2, 3 to 2, 3 to 2. It's the same computation for the new index that you're going to get. So this is also another practical instance that we need to discuss under the indexing. Right. See this. Another question, rise in GDP deflator means GDP is improving. It merely not be the case, because GDP deflator, I reiterate, it's the index that you're going to consider merely looking at the changes of price level. So you can't really comment on whether a GDP is increasing or not merely by looking at the GDP deflator. Rather, you have to look into other aspects such as the actual levels of consumption and many more variables to comment on that. So yeah, so that's an extension of a question, nothing to be done with the stat, rather other subject areas. So I reiterate, GDP deflator, these real wages and nominal wages, these are just to show you some of the examples of these indexes and their real usages. Okay. So before we finish the discussion, there's one more I want to share with you. That is some of these widely used indices in Sri Lanka. NCPI or the inflation index is one of the most important index in the country that measures the inflation. Wholesale price index is also another index that is also to do with the price levels of a country in Sri Lanka also. So for the wholesale items like coconut, then rice, sugar, flour, you have the wholesale price index also published in the country. All share price index and S&P SL20 index are also some indicators in the share market, that is to give you an understanding whether the prices in the country in the shares has gone up or gone down. Unfortunately, to my knowledge, government securities market does not have official indices, but some of the Indian institutes like there are a couple of institutes that they are publishing the indices, and some systems like Bloomberg also publish some of the indices, but nothing officially being published by a regulator. So similar to these indices that you see for inflation, similar to indices that you see in the capital market, there could be many more hundreds of different indices calculated in this country. For instance, if you look into domains like healthcare sector, uh, how do you think that BMI index comes into place? Body mass weight index. So that is being using thousands and hundreds of thousands of data of people, Sri Lankan people in the healthcare system, and they define the average. They do the sampling, they do the standard normal distribution, and they define with a confidence interval of 99.7%. This is your range of weight. So indices are being used in heavily used in finance and economics, I reiterated, but it's not the only case, but it's been used in many more industries as well. That's about the theory that we need to discuss under this week for the indexing. That finishes also the indexing theory. It's not a major lesson like mean, median, and mode, where you have variance, standard deviation, covariance, different equations to keep in mind. Not like the regression where you have to do different computations. This is a very interesting standalone subject area, as long as you know the basis of last players and partial index, and some practical implications like those what we discussed, and importantly doing a rebasing also. You should be able to comfortably score some good marks at the examination. And keeping the examination aside, hope you got some insight into indexing for your knowledge as well. So that's about today's lesson. We will meet up in the next lecture, hopefully with the completion of the entirety of the questions, or if not, the at least by one question, by one types of questions that is being tested in the recent examinations. Okay. Before we wind up, I just want to shed some light on the next week's plans also. So obviously now we are about to go towards the end of these discussions. So we are only left with a couple of standalone areas, and then the next big thing that we are going to discuss is going to be the application side of this statistics, where we shall be looking at a couple of individual sessions on few aspects. So hopefully next week we will try to cover the modeling, which shall be an extension of the regression and couple of sessions we covered. And once we covered the section on modeling, obviously we are done with the most of the standalone areas. Then we have to focus on the subject area on the selected financial applications. So earmarked areas given in your guideline. It says on bond pricing, yield curve estimation, present value calculation, portfolio theory, and some couple of areas. But if you look at the questions being tested in these particular areas, these areas on bond pricing, NPV, project appraisal, and portfolio theory are the most questioned areas. So obviously, we will try to spend at least one class per these areas, and provided, depending on the number of questions that is been there in the papers, obviously we will go through the questions separately. So with that, let's meet up on the next week with the section on modeling. We will, sorry, before that, we are going to discuss some of the questions being tested in the indexing. Hopefully, we should be able to cover that pretty soon. And then we will start up the theory on the modeling. So once we are done with the modeling, obviously, we are focusing on the standalone areas on bond pricing, NPV, and portfolio theory. Now, those are very important sessions. Don't try to miss them. We'll work through some of the examples, and also I mean, if you look at areas like bond pricing and portfolio theory, obviously there are plenty of opportunities for you to score some good marks. So this selected financial applications, this area is going to be very much interesting for your knowledge as well as for your examination, right? So thank you, and we'll meet up on the next week.